So we talk about flow rate. There are many types of flow rate, but flow rate means that it is a fluid movement from one point to another. Okay, imagine there is a stream. So from one point to another, there is some flow comes in. So we can measure that in terms of mass flow rate. Okay, usually we denote as m dot here, and it can be in terms of mass per time, which is can be pound mass, can be kilogram, gram per hour, per second, per minutes. We can also have volumetric flow rate, which is the v dot. Okay, it can be volume, which is in the feet cube, centimeter cube, meter cube, liter per unit time. And we have molar flow rate, and we have here denoted as n dot. The molar flow rate, it can be like a mole, gram per mole, kilomole, pound per mole per unit time. So in industries, we use rotameter and orifice to measure the volumetric flow rate for any process stream. And in addition, we can also use mass flow rate, so that this mass flow rate will be given. It can measure the mass flow. It's called mass flow meter, so that we can use to measure mass flow rate. And otherwise, by knowing, for example, by knowing volume, and we know the density of each component, we can actually convert between mass and volumetric flow rate. So when we talk about flow, so these are the examples of flow that is that can be that we can see normally in a process variables, such as the mass flow examples. You can see that, for example, 10 kilogram per minute, 1 pound per second, 3 milligram per day. So this is the example of mass flow. If we talk about mole flow, it's like 1 mole water per minute, all right, 3.02 kilomole per hour of certain component, 135 pound mole per second. So this is molar flow rate examples. And volume flow examples such as 10 meter cube per hour, 4.5 meter per day, and so on. And when we talk about, just now we talk about mass flow rate and the flow rate itself. Then now we would like to talk about mass, volume, and density. So we know that density can be represented by mass over volume, and the units can be gram per centimeter cube or kilogram per meter cube, and so on. And on top of that, we can also use specific gravity to measure a ratio of density of a substance to density of reference, such that if, let's say, we have one reference of density, usually water, which is at 1.000 gram per cm cube, we can calculate the specific gravity with respect to water of a certain of other component. For example, we calculate the density of alcohols, of ethanol, of methanol, for example, with respect to water. What is the specific gravity? So we get to know what is the specific gravity for methanol, and then we divide it by the specific gravity of water. At the same time, we can use the density so that we can calculate many other things, such as we can also calculate molar densities, okay, which is N over V, or it's also equals to rho over M. We can also calculate specific volume, okay, such as V over M, which is specific volume is the invert of the density, and the molar volume, which is V over N, and is also can be done is equals to mass over density, M over rho.